Right, so we're going to do a little bit more differentiation, but this time we're going to look at some real life problems. Um, and really, it's like if you could work out dy over dx, you can find out the gradient, and you understand about why you're actually looking at a second order derivative as well. Um, then it shouldn't be too scary, this, but a lot of people find this really difficult because you're just changing the letters. We're quite used to working out dy over dx, and suddenly we're doing different things. You kind of got v might stand for volume. We might an a for area. We've got different things going on here, and here I've got an x and a t. So let's just have a look at this example. Right, so we're going to look at some questions involving speed and acceleration. So a car pulls away from a junction, travels x meters in t seconds. For the first 10 seconds, its journey is modelled by the equation x equals 2t squared. So let's have a little look and see what this actually looks like on a graph. If it was y equals 2x squared, then I'd probably tell you to draw a graph. Now, on this again, this looks a bit weird because x, I'm saying to go and put over there. Well, it's the response variable. So, like I said, normally it says y equals, this says x equals. So, why not draw it the other way around? So, we've got t just there. And all we're going to do is let's just draw a quick sketch of, this is just a basic quadratic. And there we go. And what are we actually being asked to do? Oh, it says for the first 10 seconds. So, let's put a 10 just there. It's going from 0. See, I'm not going to do negatives there. So what is the question? The question is basically, it says find the speed of the car after 8 seconds. So it's just asking us to find out the gradient when t is equal, oh, I just touch that, when t is equal to 8. So what's it asking us to do? Let's write it down. So we've got x equals 2t squared. So rather than writing dy over dx, so our first order derivative here, look, a bit of a Star Wars insert there. So I was watching Star Wars last night. There we go. So dx over dt. Like I said, if this was a y and an x, you wouldn't panic. Lots of people now panic. It's exactly the same. What's that going to be? 4t. So when t is equal to 8, okay, so I'll just move that over a little bit more so you can actually see the full question. When t is equal to 8, if we just go and pop that in for ourselves, then dx over dt would equal 32. So in other words, 32 meters per second. There we go. All right, all done. Right. So how might the question be extended from here? Well, what about if I was asked to work out the acceleration during this period? Okay, now, first of all, just thinking about what does acceleration actually mean? Okay, so acceleration is the rate of change of speed with respect to time. So what does that actually asking us to do? All it's asking us to do is to find the second order derivative. So it's just asking us to work that out, which in this case is really quite easy. All right, most maths is relatively straightforward as long as you know what it's actually asking you to do. When it's y and x, it's straightforward, and then when we start changing the letters, change the context of the question, then it just adds a little bit of confusion. So remember, dx over dt is equal to 4t. So therefore, second order, just get used to writing the letters down that equal 4. So the answer, that's our acceleration just there. All right, so I've got doing a few questions, and the questions are all the same sort of idea. Rather than having x's and t's, they're basically they're x's and t's rather than y's and x. Okay, but they're all basically the same thing to go and do. Right, so I've got doing a few questions and